This video will be a little bit different. In this video, we are going to build an RGB LED driver PCB for the WLED program. I also made this video as a two-part. In the first part, we will be talking about how I designed the PCB and the component that I used. On the second part, we will assemble the PCB, the different enclosure, and also test the circuit. So the goal of this project is to build a 12-volt 3-channel PWM-LED driver, and each channel will be controlled red, green, and blue LEDs. So we're going to use the Xiao ESP32C3 for creating this PWM. Also, I used this circuit diagram actually found on WLED wiki page as a reference, using IRL Z44N MOSFET for this project. This is a low level MOSFET, so it actually only need a small amount of voltage in order to open the gate. So it is actually pretty good MOSFET to work with an ESP32. We will take this design as a reference in order to design our circuit. Okay, now we are on the flex. First thing to do is importing most of the components that we actually needed for this project. First of all, we will search for our Xiao ESP32C3. Next, we need to power our ESP32C3 using a 3.3 volt source. So we need a voltage regulator for this. We are gonna use the AMS 117 for this. 1117. We can't find it. Okay. The next thing, we need to have two capacitors on the input and output of this voltage regulator. We're gonna using a 10 UF tantalum capacitor for this project. So I'm actually using this specific part, and we actually need two of them, so you can actually drag it, or you can actually copy and paste it. So in order to rotate the one symbol, you need to press the semicolon button on your keyboard in order to rotate this symbol. So if you need to flip the symbol, you can also do this by clicking F on the keyboard. Next, we need to import the transistor. So we're gonna search for IRL transistor that we're gonna use. Here is it. Next, we need to import a 10K resistor. You can actually search for that in here. Next is the resistor, the 10K. Next, we need to find some wire terminals. I'm gonna use this specific part. This is a 2-pin wire terminal. We actually need 4 of them. You can actually copy and paste it like 4 times. Now we can actually start the wiring process from the power section. I'm gonna flip this symbol using the F key. Next, we can actually start the wiring. You can actually find some ground net. We can actually use this to connect our ground, and also we can actually use net portal. This method will be much more easier in order to design a circuit, so you didn't need to directly connect this 3-volt output directly to our Xiao ESP32C3. So we can actually rename this net into 3v3 into 3 volt, and we can actually copy this net and paste this on and paste this to our Xiao ESP32C3 3-volt input. Now we have a connection between the output of the voltage regulator and the Xiao. So next we can actually copy and paste this net again, and you can actually place this on the input. So the input voltage will be like 12 volt. So you can actually use this principle in order to design the schematic. So I will design the rest of the schematic. You can actually see that in here. So we are actually done with the schematic here. So you can see we actually connected like the red, green, and blue LEDs GPIOs here. Note these GPIO numbers because you actually need to assign these GPIO values onto the WLED program data. I also placed like 2 M2 holes in here. You can actually find those in here on the part list. So we are actually done with our circuit diagram. Now we can actually jump back to our PCB designing tool. Okay, now we are on the PCB designing tab. So in here, basically you can actually change the dimension of your PCB, and also you can actually round the corners of your PCB in here. Also before actually starting the designing, currently we are actually working with 4-layer PCB right now, but we actually only need like 2-layer PCB for this project. Done this by clicking on the layout. You can actually go to the stack up and select 2-layer. Okay, now we are actually working on 2-layer right now. Now you can actually select each of the components and drag it in place. Also you can rotate this component by clicking on the semicolon, and also if you need to change the designator, you just need to click on the designator and drag it around. And also we can actually place our screw holes like in here. So I will show you some of the essential thing you need to know in order to design PCB on this flex. If you need to connect two pads together, you just need to click on the one pad and to the other pad, and the connection will be established. If you need to make your trace go under this PCB line, you just need to use something called vias. This will actually allow you to connect your trace from the first layer to the second layer. You can actually done this by right clicking, and you need to select the bottom copper layer. Now the PCB layer will be going under the PCB. In order to bring back this trace to the top layer, you just need to right click and click on top layer. This will help you to create vias much more easily. So using this principle, I will be going to place each of the components, and I will design this PCB. So we are actually done with the doubting all of our PCB trays. Next thing to do is we need to add some copper fill, but thankfully the flux.ai is already done the copper fill automatically for us. You just need to enable it in here. Now you can actually go to the 3D preview of this design. The reason I actually put this resistor on the side is you can actually easily bend this MOSFET over here and the resistor will not interfere. So we are actually done with our PCB designing. It's looking good, I guess. So in order to export this to a Gerber file, you just need to click on the flex icon and export, and click on the Gerber file. Now the Gerber file will be generated and it will be downloaded here. Okay, I'm actually going to use the Studio Fusion service for manufacturing this PCB. You can upload this over your Gerber file to the website by clicking on add Gerber file, and you need to wait for a second here. Okay, now we are actually going to place this order for the PCB and wait for the PCB to arrive. On the part 2, we will be trying to assembling this PCB, and we will 3D print an enclosure for it and test it. So thanks for watching this video, guys. Happy making.